forward to the next one being just as well. We do have a test next Friday already. The reason why I have a quick turnaround, we're still just talking about area and perimeter. We're just including circles and a couple other shapes in there. Okay? So the good news about a quick turnaround for our test is it's less material, right? Because next Thursday we'll already be reviewing, so I really only have 5 days and then 3 days, and then we're taking a test. Okay, today we're just talking about circles, and I'm sure many of you have seen areas of circle, circumference of circle before, so most of this is hopefully just kind of a review. The questions will just be a little bit tougher. So the first thing we're going to talk about is pi. Who knows what pi is?
The ratio of the circumference to the diameter.
It is, actually.
And that's for every single circle.
It is for every single circle to the... in fact, I was expecting, like the other class, they gave me the 3.141. They actually listed it out, which is fine, because that's... That's the one. Yeah, I don't even know how to memorize that far.
I got a T-shirt for that.
Oh, you got oh, okay. Is that why?
Oh, I hated that.
Oh, there was a song for it too?
And it kept going.
But then you know it.
No, that's bad.
That's bad. We don't need to know it. Our calculator knows it, right? Our best, the only time I'm ever have you round pi will be 3.14. But I'm never going to ask you to do that, because if you look at your calculator, it has a pi button on it. You should never round pi. Let your calculator round pi. So if I do 3 times pi, never do, well, that's 3 times 3.14. Do 3 times, hit the pi button, let your calculator round it from there, okay? And most of the time our answer is going to have pi in it. We're not even going to do anything with it. All right, so pi is the circumference to the diameter. It's that ratio. And just like Madsen said, that works for every circle, and that's where pi comes from. It's not just made up number that just happens to work for area and circumference. It comes from that. So if I measured this whole circle, right, and then I measured the diameter, and even though my measurement is probably going to be a little inaccurate, because maybe I use a ruler or something, if I measured that and I took this full circumference length and I divided it by that diameter length, it would come out to 3.14-ish. Because like I said, you have a little bit of error when you use like a ruler or something. But that works for any circle. So if you see a giant circle and you measure the whole thing, divide it by the diameter, you're going to come out with 3.14. It's actually pretty cool. We just don't have time to measure circles and diameters, because it's not the first time you've seen pi. But it's a pretty cool activity. If you don't believe me, go home, measure a circle. What I always do is I just take a string, go across, and then measure it against like a ruler, measure the diameter. It's going to come out to about 3.14. So it's not a made-up number. It's a real number that comes from the circle. So in order to talk about circumference and diameter, I first have to know what a diameter is. Well, a diameter is just that special chord that runs right down the middle. And this should hopefully be just review for most of you, or for all of you, hopefully. So that's my diameter. And we also need to know radius. Well, radius is just half that distance. In other words, it's from the center of the circle to the outside of the circle. That's my radius. Mind-blowing stuff, I'm sure. All right, then we're just going to define what circumference means, in case I'm throwing that word out and you're just like, I know it has to do with the circle, but I don't know what it does. Our circumference is basically, what I like to think of it as, it's just the perimeter of a circle. It's just that distance all the way around. That is my circumference. And area still holds the same value. It's just that all that's on the inside. So my area, just like with a square, is all of the circle. It is, if I bought pavement, how much do I need to buy in order to pave that giant circle? Where circumference is, well, I'm walking around a circle. How far did I walk? Area, I need to pour something over it. Circumference, how far does it take me to walk around it? All right, those are our key terms when we're dealing with circles. So now we're going to talk about circumference. Circumference of a circle with radius r. So if I give you r, and I give you my radius, does anyone know the formula for circumference? If I give you radius. Imagine you already gave me that awesome pi answer. How'd you?
2 pi r.
2 pi r, awesome. So we do remember. Well, now we're going to talk about circumference if I give you diameter. Well, the cool thing about diameter is equals 2r, right? If I line up two radius together, or two radii, it's one diameter. So 2r, in fact, just equals our diameter. So if I'm just dealing with diameter, I can say my circumference just equals pi times d, or d times pi. So if I give you diameter, it's just diameter times pi. That gives you my circumference. It's that walking. If I give you radius, it's just 2 pi times that radius. All right, now we're going to talk about area. Who remembers the area of a circle formula? I'll give you a hint. It has pi in it. Anyone want to take a shot? Anyone want to get it completely wrong and just make up something? That's what I would do. Fritz wants to make up something. What are you going to make up?
It equals pi.
What was that?
It equals pi.
It just equals pi? That's a
Yeah.
good guess. Has something to do with pi. Anyone else want to just take a guess? I mean, life is full of mistakes. Jack, you want to take a guess? Just take a guess. Make it up.
R squared.
Pi r. Oh.
Where'd you get that from? It's a pretty good guess.
You sounded so excited about it too. Pi r squared. It is pi r squared. I don't know why it's so miserable. It is pi r squared. And those are our three major formulas. We can also do that with diameter, because diameter, we can just take our diameter, say my diameter is 10. I know my radius is 5, right? So that would just be half our diameter squared. That's all radius is. So we're going to rewrite that down there. And just for repetition's sake, we're going to write all of those again. We're going to do it in like a flow chart, kind of like I'm a computer program, right? I'm asked to find a circumference. And now I need to ask, am I given the radius or am I given the diameter? Because that's going to depend on which of the two formulas I'm going to use. Well, let's say I'm going down this. I have a circumference. I'm given a radius. Our formula we're going to use is 2 pi times r. Now I'm still looking for some circumference, and it turns out my word problem gives me diameter. There's two ways we could do it. We could say, well, I know diameter is 2 times radius, so I can say, well, I'll just take my diameter, divide by 2, and plug it in here. That's fine. Or we could just say, well, I could just take my diameter and just say, well, it's pi times my diameter. Sometimes this is nicer. I don't have to worry about dividing. I just plug it right in. Rather than dividing by 2 and then multiplying by 2, takes a little bit of time. All right, now I'm going to find area. Once again, I have to know if I'm given my radius or my diameter. If I'm given my radius, it's going to be that exact same formula that Jack so emphatically gave us. It is pi r squared. Yeah.
I have like a guess for the next
Oh, for the next one? Okay. So I'm looking for area. I'm given the diameter. I don't want to use r in it. How could I rewrite it?
Would it be A equals pi parentheses D over 2 parentheses squared?
Absolutely. D over 2 squared. A lot of times we could just do this in our head. So I'm not giving you some crazy, your diameter is 15.77311115. I'm probably going to give you something that you can find the half of. So a lot of times I'll just give you diameter of 10. Either you plug it in or you're just like, well, 10 divided by 2 is 5. I'm just going to say it's pi times 5 squared. But it's always nice to have that formula in our back pocket just in case I just want to deal with diameter. All right, so that's kind of our flow chart. We'll probably write all these again tomorrow. But we're going to move on to a couple examples. So example 1. What is the area and circumference of a circle with radius 10? These should be the fastest ones. If I ever give you diameter or if I give you radius, you're in the money. It should just be plugging stuff in. All right? Diameter, diameter and radius pretty much get an answer. So if I'm looking for my area, we just have to remember that area equals pi r squared. Well, our radius for this one is 10, so it's pi times 10 squared. So my radius is 10 squared, which is 100. Well, it's just 100 pi. All right, once I get my circumference, I'm going through my checklist. I'm given my radius. So my circumference is going to be 2 pi r. Once again, my radius is just 10. 2 pi times 10. Well, last time I checked, 2 times 10 is 20, so that's just 20 pi. So 100 is my area. Circumference is 20 pi. Unless for some reason you're dealing with some super tiny, tiny circle, your circumference should always be bigger, or your area should always be bigger than your circumference, right? Because it doesn't make sense if I walk around a circle if I walked further than if I walked up and down it. All right, so just do that check. If I give you circumference and area, all of a sudden your circumference is huge, it's just like, well, maybe I made a mistake. All right, it's a good little check. All right, the next one's a little bit different. It says, what is the diameter of a circle with circumference 10 or 16 pi? Can I read? No. All right. So what I picked from this one is I need diameter and I have circumference. So I'm just going to use my circumference formula because they didn't give me diameter, they didn't give me radius yet. So I know I'm dealing with diameter and I know I'm dealing with circumference. So I'm going to write down my circumference formula. Well, circumference equals, what does circumference equals if I'm dealing with diameter? What is that formula if I'm dealing with diameter? Right?
Pi d.
Pi d. Well, it says here my circumference is actually 16 pi. So we're going to replace my circumference with 16 pi, and that's going to equal, I'm just going to rewrite this as d times pi. What does d have to equal, Brian?
4.
Has to equal, not 4.
Oh.
If 16 pi has to equal d times pi, what does d have to be?
Oh, 16.
It has to be 16. So either you can just see that, either you can say, well, if 16 pi, this must be 16 to be 16 pi, right? So either you see that, or you're just like, well, I missed that. But if I was simplifying this, I would divide both sides by pi to get my d all by itself. Well, that would eliminate my pi's, and you would still come up with 16 equals the diameter. So either solve that equation, or just recognize if something times pi equals something times pi, both those somethings must be the same. All right, because both sides have to stay balanced, right? If I put 16 5-pound weights on one side, and I want to keep it balanced, I better have 16 5-pound weights on the other side. All right, so that's how we keep all those the same. So our diameter equals 16. All right, the very last thing we need to talk about is finding the area and circumference of a shaded region. The big thing here is we need to know how much is being taken up by that shaded region. Isabel, well, how much of the circle do you think this is? 1/4. It's about a quarter. And I would give you the exact dimensions of it later on. So this is about a quarter of the circle, so that would be like 25%, right? Let's just leave it as a quarter, but we could think of it as 25%. And we'll talk about why I'm talking about percents in just a second. So that's a quarter of the circle. Wait, if that's a quarter of a circle, if I found the total area and I just took a quarter of it, that'd be that guy, right? And if I took how long it took me to walk all the way around this and I took a quarter of that, that's how long or how far I'd walk a quarter of it. So when I take arcs of things, we're just going to still get the total area of our circle. We're just going to figure out what a quarter of that total area is, or what a quarter of that circumference is going to be. So that quarter is all we really need to know, and we need to know how to get circumference and area. So we're going to start with, I can't remember how I labeled it. Just want to make sure it's the same. So I did. I said total circle. So the first thing we're going to do is we're going to find our total circle. So our total circle. Well, our total circle, if I want to find the area or the circumference, we already did it. Because the radius is 10, and if you look right above it, I asked you to find the area and circumference of a circle with 10. So we already did it. We're not going to do it again. So maybe we'll just put a little line down here to there, and we're just going to go right to the fact that area equals 100 pi, and circumference was our 20 pi. All right, our shaded region, the shaded region. We said, or Isabel said, that that's a quarter. That's a quarter of our circle is shaded. Well, that means a quarter of this area gives me my shaded region. So all we have to do is take our area of this one is going to equal 1/4 of our total area of 100 pi, which is just going to equal 25 pi. We're going to do the exact same thing for circumference. Circumference is going to be 1/4 of what my total circumference was, which is 20 pi, which just equals 5 pi. So if I'm given an arc or a shaded region of a circle, I need to do two things. I need to get my total area or my total circumference, depending on what they're asking for, and then it's got to figure out how much of that circle is being taken up. And this one is pretty obvious. We said this looked like a quarter, so we left it a quarter. We won't always be given like a quarter or something like that. Most likely, they're going to tell us what degree measure it is. All right? So most likely, you're going to see something that's like this. This is 90 degrees. Well, if that's 90 degrees and I want to get the percent of the circle that's taken up, I would take 90 divided by 360. Just like when you're figuring out your grades, you figure out what I got and you divide it by the total amount, right? So if I had a 50-point quiz and I got a 45, I'd do 45 divided by 50. That gives me my percent I did in the test. Same thing here. If I do 90 divided by 360 and you plug that in your calculator, that should come out to 0.25, right? And does that work? Yeah, okay. So that means our equation for length, and this is also going to work for area. The only difference between area and length is if I ask for the area, you're just going to take your area formula and put it in its place. So I'd put pi r squared instead for area. And we'll do a little bit for the bell work tomorrow. But for today, we're just looking at length. So length of this A to B, that's going to equal whatever degree they give you divided by 360. And like I said, this whole calculation right here is just finding the percent of the circle. So that's finding my percent of the circle. One above was 25%. Like we said, if we did 90 divided by 360, it came up to 0.25, which is 25%. So we do the percent of the circle that's being taken up, and we multiply it by the total circumference. So that 2 pi r is just our circumference. Yeah?
So it's the same as just you're taking a fraction of the circumference?
That's exactly what I'm doing. I'm taking a fraction of the circumference. That's all I'm taking. Maybe I should not put circ, because that looks like circle. Let's not get lazy now. Put the full thing, circumference. But Mazen had a great way of saying it's just a fraction of our circumference. Because obviously I didn't walk all the way around the circle, I just walked this much. I want to figure out what percent of the circle I actually walked around. That's this guy. This is our total length, so if this was 100, I only walked, whatever percent of 100 I actually walked. All right, questions on that? So on these, we're going to need two things. I'm going to need my total circumference or total area, and then I need to know what percent of the circle I'm talking about. And that's by doing whatever degree they give me, divided by 360. So let's go ahead and try one of these. All right, in circle A, we have an inscribed angle BCD that equals 36 degrees. So let's stop right there because that's some terminology we haven't seen in a little bit. So an inscribed angle. An inscribed angle is one that goes right to the center of the circle and looks something like that. I don't know exactly how big it is, but we know an inscribed angle is going to look something like that. And it was the inscribed angle BCD, and it's supposed to be 36 degrees. Not a super accurate drawing because that's way past 36 degrees, but it doesn't matter. The numbers are what matter, and what they're asking is what matters. Hey, if this is 36 degrees, what's the measure of what's the degree measure of my arc? Mazen?
Wait, if it's inscribed?
If it's inscribed, it's 36 degrees. What's the degree measure of my arc?
72.
Nope.
36.
It's going to be 36.
Is it a central angle?
Yeah, it's a central angle.
What is it called when it like touches the edges?
Chords.
Like when the angle like goes back and like the angle of the arc equals 2 times.
Yeah, you were absolutely right. I didn't mean to write it like that. That's a good catch, actually. Inscribed is actually, yeah. That's not what I wanted, but let's just do it that way. Good catch, Mazen. Yeah, inscribed would actually go all the way to the back. I meant to say central angle. But we can still solve it all the same. So this is B, C, D. That was a good catch. All right, so that's 36 degrees. So that means Mazen was 100% right that this is actually 72 degrees. So that measure between B and D is 72 degrees. And it says the radius is 24 centimeters. Our radius is 24 centimeters. So remember, if I'm looking for length of BC, we're going to use that formula. That first I'm going to find out that percent of the angle that's being taken up. That's 72 degrees divided by 360. And I'm going to multiply that by our total circumference, which is 2 pi times r. Well, my radius is 10 or 24 in this one. So it's 2 pi times 24. All right, then what I'm going to do is I would do 72 divided by 360. Yeah, that makes sense. So it's going to be 0.2 times 48 pi, which is going to equal 2 times 4.8 actually. So you should come up with 9.6 pi. See, I meant it to be a central angle, but it all still works out, right? As long as we can find this arc, we're good and we know the radius. The two things we need to know is that arc and that radius, and we're good no matter what problem I give you. All right, are there any questions on anything I did up here? Because this is almost as easy as it gets. All right, because they pretty much give us the arc. All right, our next one's going to be a little bit different. This one says in circle G. So we have a circle called G, so that means that we have a circle. We got this guy in the middle. That's G. That's what it means to be circle G, is that point in the middle is called G. And it says measure of JR equals 108 degrees. So if I make a J and an R, And I'm going to put it on the inside because we got to put something on the outside. So that total distance, or that total degree measure is going to be 108 degrees. That's 108 degrees. It also says the length of JR is 9 pi. Well, that just tells me from here to here, this actual distance, if I measured it, is going to equal 9 pi. Here's my advice on a problem like this, and what some of you are lacking on tests. If you're not sure what to do, write down a formula. Alright, because at least if you write down a formula, I know you're thinking of something versus just going crazy on it. So what I'm going to do is I'm going to write down a formula, and I know it has to do with length, because they talk about length of JR. Alright, I know for that formula that the length of JR is going to equal x divided by 360 degrees times 2 pi times the radius. As soon as you have a formula down, all you're going to do is fill in any information that you can and see if it helps you solve it. So we know the length of JR. It says the length of JR is 9 pi. So in place of JR, since I know this length, I'm just going to put 9 pi in its place. I also know the degree measure of JR. Ooh, I should put an R on there. I dropped that off. We also know the degree of JR, which is 108 degrees. So we have 108 degrees over 360 degrees times 2 pi. That's just a number. The only thing I don't know is that R, so that R is going to remain. The rest are just numbers. That's a number, that's a number, that's a number. The only thing left is R, so we just need to solve for R. There's a few ways to solve for R. I'm just going to do the kind of quicker. So I'm going to take that 108 divided by 360. I'm going to multiply it by 2. Alright, so that's going to give me 9 pi equals 0.6 pi R. Well, I still need to get R by itself, so we need to get rid of that 0.6 pi, which means I'm just going to divide, because then it turns into 1. That means I have to divide the other side by 0.6 pi as well. And we're going to see that R is just going to equal 15, because pi divided by pi would turn to 1 also, and you're just left with 9 divided by 0.6, and that comes up with R equals 15. Any questions on that? Okay, so the hardest thing we did today was arc length. That's going to be the hardest ones to deal with. Everything else is just area and circumference. You should have seen that before. I do want to go over 2 questions really quick. First thing, if you look at 11 and 12, look at 11 and 12, the drawings for them are actually on the next page. I must have hit enter really quick before I actually printed them off. So 11 actually goes with this drawing, 12 actually goes with this drawing. I don't even have room for that. Alright, the other thing I want to talk about is number 13. There's a bunch of questions on there, but the only one I really care about is what is the measure of the angle formed by the hands of a clock at 10:20. The rest of the questions are just kind of help you, guide you. But what I want to say, I want to talk about how a clock works really quick. It sounds ridiculous, but it's true.